If your BizTalk application is processing XML documents, and that of course includes flat files that have been converted to XML documents, then you can take advantage of a feature that BizTalk offers that's known as mapping. And BizTalk maps allow us to transform our data from one XML format to another. We can start rearranging the order of fields. We can start modifying and combining values. We can perform mathematical operations. And if this happens to sound like my description of XSL transformations at the beginning of Module 2, well, that's because BizTalk maps actually are XSL transformations. It's probably safe to say that programming with XSLT is kind of an acquired taste. Not everyone wants to endure that learning curve, but the capabilities that it offers are very nice. And so what BizTalk does is it gives you a way to create these maps, but you don't necessarily need to be concerned with exploring the depths of the XSLT specification. The BizTalk mapper lets you take advantage of the power that XSLT offers. And in fact, you might even see maps sometimes that could be considered applications unto themselves. These things can grow very sophisticated. Fortunately, there have been some dramatic improvements in the mapper in BizTalk Server 2010. So let's take a closer look at BizTalk maps. Let's see what they can do for us, and let's see what we need to know to create one. I mentioned that BizTalk maps can actually become very sophisticated, and so let's take this in stages. We'll start by looking at the basic capabilities that maps offer, and then we'll take a look at some of the extensions that the BizTalk mapper provides. The XSLT specification leaves the door open for extending the capability of the core language. And BizTalk provides a number of useful functions that you can add to your maps, and those are known as functoids. So in Lesson 2, we'll take a look at some of the basic functoids that are available, and then we'll build on that in Lesson 3 by looking at some of the more advanced functoids. In the first lesson of this module, we'll take a look at what BizTalk maps actually are, and when you might want to use one in your applications. And then we'll take a closer look at the BizTalk mapper and see how it helps us create these things. We'll talk about how you can use links to define transformation rules in your maps. And then similar to what you saw with schemas, BizTalk integrates some features within Visual Studio that help you test and validate your maps. And then after that, I will show you what it looks like to create a new map in Visual Studio. Since BizTalk is an integration server and it coordinates between systems to carry out an automated business process, it bears the responsibility of communicating with each of those systems in their native tongue. As a result, BizTalk will frequently need to accept data in one format and convert it to another format. So in this slide, we can see two schemas that represent purchase orders. Now we don't know exactly what these two purchase order schemas represent, but there are a few different possibilities. First, the schema on the left could represent a purchase order that we are accepting from a trading partner. And then the schema on the right could represent the format of our accounting system. So we could have a BizTalk map that translates from our trading partner's format to our accounting system's format. Or something similar to the reverse could be true. The schema on the left might represent a message from our purchasing system, and the schema on the right could represent the format of one of our trading partners. There's another possibility as well. As organizations start to implement more complex integration scenarios, it's common to define a set of internal schemas that are often referred to as canonical schemas. These canonical schemas are intended to be more complete than the schemas of any one particular system. And the ultimate goal of a canonical schema is that it allows us to think more in terms of a business process than to get bogged down in the details of individual systems. So in terms of this slide, if we accept a message from a trading partner, the first thing that we would want to do is convert the message from our trading partner's format to our own canonical schema. Then we can perform the internal processing, delivering that purchase order information around to the various systems as required. And as those messages are delivered to each individual system, Then BizTalk can perform the mapping from the canonical format to the format of an individual system as it needs. And that could potentially reduce the number of maps we need to implement our integration solutions. We no longer need individual maps to go in between each individual system. We now just need a map to go from an individual system format to the canonical, and from the canonical back to that individual system format. Then we don't have to worry about the potential for exponential growth in the number of maps as we add more and more systems into our integration environment. So you'll hear the terms data transformation and data translation. I wouldn't worry too much about trying to determine a distinction between those two. The central idea in both cases is that you're taking data in one format, converting it to another format, so that each system can understand the data that it is receiving. So in short, maps play a fundamental role in BizTalk integration solutions, since they allow BizTalk to communicate with each individual system in its own native tongue. Now, what exactly is a map? I mentioned earlier that a map is ultimately an XSL transformation. You're going to be using the BizTalk Mapper tool to create links between fields, such as you see in this slide. But the needs for any given application could very well be more complex. What happens, for example, in this scenario, if the status code for the source message is not a valid status code in the destination message? The BizTalk Mapper provides functions that you can use to perform those types of conversions. And in that case, you might need to perform a lookup to determine the corresponding code that goes from the source message to the destination message. Another example might be the date format. If our destination system does not understand the format of the date provided in our source message, we may have to perform some sort of string manipulation to convert that date into a format that the destination system understands. Another possibility is that our destination system might be able to accept alphanumeric item numbers, but it requires them to be in all caps. And our source system might have no such requirement. And so we might need to map that value over, and in the process we would have to ensure that all lowercase characters have been converted to uppercase as the value was carried over. So we're talking about a couple of very simple schemas here, but even in this type of scenario, it may not be as simple as just copying values from left to right. And so fortunately, the BizTalk Mapper makes it very easy to handle any of those conversions. And speaking of the BizTalk Mapper, let's see how it can help us. When you open a BizTalk map in Visual Studio, you will see it displayed in the Mapper window. And on the left-hand side of the map, you'll see the source schema. So this would be a schema in your own project, or this could be a schema in a project or assembly that you have referenced. And then over to the right, you will see the destination schema. This map is going to take values from a sales order message, and it is going to use those to populate a loan application. In the middle, you will see the map grid. This is the working area. And it's on the map grid that you define the rules for mapping to some particular field in the destination schema. And you can see in the toolbar at the top, the mapper provides the capability to pan and zoom. And this updated version of the mapper provides some very nice search capability as well. It's very easy to create a link in the mapper. A link simply specifies that you want to copy the value as is from the source to the destination. And you can link two nodes by simply dragging and dropping one to the other. Eventually, you will probably encounter a schema in which you need to map a source record to the destination record. In other words, an element in the source schema has child nodes, whether those be attributes or child elements, and those correspond to an element in the destination schema that has child nodes. If the record is small, it's probably not a big issue to map the individual fields. But if the records are large, that could become kind of tedious. So the BizTalk mapper tries to help here in a couple of ways. If the structure of the two records is similar, you can ask BizTalk to help you create links by following the structure of the two records. And in that case, you would simply drag the record node from the source to the destination, and BizTalk would link all of the child nodes in order. If the structures were similar enough, this could save you some time. You might be able to get away with just going back and editing a handful of fields that didn't map correctly. On the other hand, if the structure of the records doesn't match, but the names of the fields within the records match, you can ask the mapper to try to match those fields by name. So you would drag the record from the source schema to the destination schema, and when prompted, choose to link by name. And then the BizTalk mapper will go about trying to match the names between the two schemas and creating the links accordingly. So the BizTalk mapper does a nice job of making it easy to create these links. You just drag elements from one side of the map to the other, and then at compile time, Visual Studio will interpret the links that you've created to generate the XSLT that copies those values from the source document to the destination document. At some point, you will encounter the situation that's illustrated by the two schemas on the bottom half of this slide. These are both purchase order schemas. The first link is straightforward. It's exactly like the other links that we've seen so far. We just want to copy the purchase order number from the left to the right. If you'll notice at the bottom of these schemas, however, they can handle multiple line items or order details. And now when we create these links, we expect the mapper to create multiple items from the source to the destination. Well, fortunately, most of that is taken care of for us. Provided that our schemas are set up correctly, we can just create the links between the fields in source and destination, and that alone is sufficient. What we don't see here is that the BizTalk mapper maintains an implied link. So at compile time, when Visual Studio is actually generating the XSLT, it will automatically create code that executes a loop to copy all of these line items over. So it literally turns into an XSLT for each loop. Now the one thing we do need to be aware of is if we test out our map and we don't see that looping behavior, there's a possibility that the problem could lie in the source schema. There's a property on each element in the schema called max occurs, and if that's left at the default value of 1, the mapper will not generate this loop in the XSLT code. So if we fix that on the schema and indicate that item is allowed to repeat, then this mapping will behave as we expect. Another thing to note here is that this behavior is taken from the source schema. If, for whatever reason, we mapped a field in the source schema that it could occur multiple times to a field in the destination schema that should not occur multiple times, our map will still end up with that loop, and so our map could end up producing an invalid document as output. So in short, the BizTalk map compiler will automatically implement this type of looping for you, and it's usually what you want. But if things aren't behaving as expected, you actually need to revisit the schemas themselves and make corrections there for your map to work correctly. So as you're developing your map, you'll want to stop and test it from time to time. The BizTalk mapper integrates a testing tool into Visual Studio. So you can access this tool by right-clicking on your map file, and then you can configure some properties on your map. You can indicate the name of the file that you want to use to test your map. You can indicate the format of that file, whether it's a flat file that needs to be converted before the map executes, or whether it's an XML file that's ready to go. And you can specify the output format, Perhaps you're mapping to a flat file schema format and you want to see the test result automatically converted to the flat file format. You can configure that. If you wish, you can configure the name of the output file that Visual Studio will create. And then you can also specify whether you want the input of your map validated against its XML schema and the output of your map validated against its XML schema. And that can help you determine if you run into an issue, whether the problem is with the test data or whether the problem is with the map. Once you have those properties configured, you can right-click on your map file and then choose Test Map. And Visual Studio will automatically send a copy of your input file through the map, and you can access the output. You can also validate the content of your map file. And then finally, with BizTalk Server 2010, you can automatically launch your map in a debugger. Now it's going to show up in that XSLT syntax. So this may be a mixed blessing. But if you can make sense of the syntax, this will allow you to walk through the map step by step. This XSLT debugger, by the way, was available in Visual Studio 2009. It's just easier to access now in 2010. In this demonstration, I'll show you how to use the BizTalk Mapper. I'll show you how to add a new map to your BizTalk project, how to specify the source schema and the destination schema for your map, how to create links between the two schemas, and how to use those options to create links between records that contain multiple child elements. Finally, I'll show you how to test and validate your maps. Alright, so we're going to create a new map to map from our purchase order flat file format to the standard purchase order XML format. So I'm going to start off by adding a new map to the project. And I'll do that by right-clicking and then choosing Add, and then New Item. And this time I'll select Map. And then this will be the purchase order flat file to purchase order map. So maps end with the .btm, BizTalk Map extension. Okay, so here's the mapper. And the first thing we need to do is we need to provide schemas for the source and destination messages. So I'll click on the link on the left to select the source schema. And so there is the purchase order flat file schema. And then I'll select the destination schema. And there is the purchase order schema. All right, I'm going to expand each of the schemas. Okay, so there we have it. We are ready to start creating some links. Notice that the address of the source schema and the address of the destination schema, the names are different, but the structure is the same. So let's link by structure. So I'm going to shift-click and drag, and then I have a menu, and then I can select from this menu to link by structure. And it automatically lined those up. So even though postal and zip don't match by name, it just followed the sequence in order. Now on the other hand, the item nodes do not follow the same structure, but some of the field names match. So in this case, let's auto-link by name. So shift, click, and drag, and then choose to link by name. So you can see that it was able to match quantity and price and description, but then we still have to manually connect the ISBN and SKU. So this is approximately what the output of our map should look like. Alright, so let's go back to the map and let's set this map up for testing. So on the properties for the map, we need to set the input. And in this case, we're going to read in a flat file, so we set that to native. And then we provide the name of the flat file that should be used for testing. And there is our test data. And we're ready to test. So we right-click on the map, choose Test Map, and the test indicates that it failed. There's still a little bit of work that we need to do in the upcoming demos. So we'll ignore these errors for now, but let's go look at the output that was produced. So if we press Control and click, we can see the XML file that was created. So the flat file was read in and processed by the map, and then that was the output that was produced. Well, the linking capability of maps is very nice all by itself, but we didn't have to look very hard to discover that we need more than the ability to simply copy values from source to destination. Sometimes we might need to alter the values or combine values as they're copied over. And the XSLT specification left open the option of adding functionality to an XSLT processor. And so the BizTalk mapper takes advantage of that by defining extra functions that you can use within your maps, and those are packaged up in components known as functoids. So as you're creating your maps, you can use these functoids to perform operations on the data that's being carried from the source to destination documents. So let's take a look at what functoids are, and we'll look at some of the basic functoids, and we'll see how we can use those in a map. So once again, we have a couple of schemas representing an order, and we need to map from the source to destination. And so for this particular application, we can copy some of these values over with simple links. There are no alterations required. Now when it comes to the purchase order number for this particular application, our source message is going to contain some prefix and suffix characters that the destination system doesn't recognize. And so our map needs to remove those. And so we need to be able to extract a substring from the purchase order number that is provided to our map. And that is where we can make use of a functoid. So what we do in that case is we add a functoid to the link in our map. Now the value of the source purchase order number is going to be passed to this string extract functoid that you see here. Each type of functoid has its own icon. And then we would configure that functoid with the parameters that are required to extract that substring. And then the functoid would pass that value to the destination document. Now, when it comes to the date field, we can see that the source document provides a date, but in this case, the destination system isn't interested in that date. It wants to know the date that this message was sent from BizTalk. So in that case, we can populate the date using the date functoid. The date functoid simply outputs a string representation of the current date. And finally, this destination schema requires a total price. It's not interested in a unit price. And so we need to multiply this quantity with the unit price, and we can use the multiplication functoid for that. So there are a number of built-in functoids. It's possible to create your own custom functoids. There's also a scripting functoid, which allows you to provide your own script code. Or you can even use the scripting functoid to call one of your own .NET classes. And so that leaves the possibilities wide open. Functoids can be very powerful, in spite of their name. The BizTalk Mapper provides a wide variety of functoids in the toolbox. You'll find functoids that help you with encoding conversions. There are functoids that calculate cumulative values, averages and sums, and so forth. And included in that is a functoid that allows you to cumulatively concatenate strings. There's a set of functoids that allow you to work with date and time values. And it offers a collection of logical functoids so that you can check for conditions such as greater than or less than or equal to. And you also can combine those with the logical and or operators and so forth. And there's a collection of mathematical functoids that includes all of the common operators that you might need. And there's even a collection of scientific functoids in case you need to calculate the sine or cosine of some particular value. And then, of course, there's a set of string manipulation functoids allowing you to concatenate and trim and extract substrings and determine the length of a string and so forth. So this map is going to create a restock message by taking the values that it needs from a sales order message. The order ID in the restock message, however, is a concatenation of fields from the sales order message. It needs to prefix the sales order number with the corresponding store number. So we can use the string concatenation functoid for something like that. And the BizTalk mapper makes it easy to add a functoid to your map. You just drag and drop a functoid from the toolbox onto your map surface. And then you connect the inputs to the functoid and then connect the functoid to the output. And then the last step is to complete the configuration of the functoid by setting any other parameters that might be required. The configuration window for each functoid provides information that will let you know what the functoid expects for parameters and the order in which those parameters should be provided. So as you start adding more and more links and functoids to your map, and as they grow in complexity, and particularly when you start dealing with larger schemas, it might be hard to find your way around your map. And so you might want to start organizing your map into sections. And you can do that by adding map grid pages. So you can separate out various functions on individual pages. So if you were mapping purchase order schemas that had a header, line items, and a footer, you could put all of the links and functoids for the header on one page, all of the links and functoids for the line items on another page, and so on for the footer. And that brings up one more improvement in the new mapper. It's much easier to move links and functoids from one map page to another. And the BizTalk mapper also provides something called the grid preview window. And that's useful if you have a large, complex map. You can use the grid preview window to quickly see the layout of your map and locate what you're looking for. In this demonstration, I'll show you how to add pages to a map, and then I'll show you how to add functoids to the map. We'll see the string concatenate functoid, the multiplication functoid, and the cumulative sum functoid. Okay, so we're back in Visual Studio with the map that we started working with earlier. And the first thing to do is that I would like to add a new page to this map to organize it. So we're going to just put all of the links that use functoids on one page, and then we'll just leave all of the basic links on a page of their own. You can use these pages for any purpose that you want. There's no need to put all of the functoids on one page or anything like that. We're just going to do that for this example. Okay, so I'm going to rename the existing page to links and then add the new page by right-clicking and choosing Add Page. And name that one Functoids. Okay, so the first functoid that we'll make use of is the string concatenate functoid. And we're going to use that to format the customer name. So we're going to take the last name and first name from the source schema, from the flat file, and then concatenate those. So you can see the documentation for the string concatenate functoid here. So I'll drag a link from the last name and a link from the first name. And then to add the comma, we need to go in and add another functoid parameter. So I'll click on the plus button and then add the comma and a space. All right, the next thing to do is to connect the functoid to the name field. You need to click somewhere on the map to deselect the functoid and then drag the link to the name field. Now the next functoid to add is the multiply functoid. We need to multiply quantity times price. Okay, and then link that to the extended price. Then the one last functoid is to calculate the order total, and that is if we create a cumulative sum, we can use the cumulative sum functoid to add up all of the extended prices to calculate the order total. So the multiplication functoid is calculating the extended price of each item, and by passing that to the cumulative sum functoid, that is going to add all of the extended price values together and then assign that to the order total field. Okay, let's test the map. Now you can see that the output document passes validation this time. And there we have the output. So the name is concatenated, and then the order total is calculated. So you've seen that by using links and the basic functoids that we've looked at so far, all of that combined with the fact that the BizTalk map compiler will automatically implement looping for us as it sees a need for it, we can create some pretty useful maps. But eventually you may encounter a situation where those features aren't sufficient to solve a particular mapping problem for your application. In that case, you might want to check out the collection of functoids known as the advanced functoids. You'll find a tab in the BizTalk Mapper toolbox that contains this set of functoids. These can help you create certain looping constructs. They can help you if you need to perform any database lookups. They can help you if you need to write custom mapping rules with script. So let's take a few minutes to see what we have in this collection of advanced functoids. I mentioned at the beginning of this module that if your source schema has a repeating record and you create links from any of the fields of that record, the map compiler will automatically create a loop to make sure that all of those repeating records are copied over to the destination. Well, you may encounter situations where the default looping behavior doesn't fulfill the needs of your application, and so you may have to take more explicit control over that looping. And that's where some of the advanced functoids can be helpful. Another situation that you might encounter is when your map should only copy a value to the destination if certain conditions are true. And that's another area in which the advanced functoids can be helpful. I mentioned the scripting functoid earlier, and if you encounter a situation where the built-in functoids just don't meet your needs, you can make use of the scripting functoid to call custom code. Or you could encounter situations where the built-in functoids could do the job, but it might just be easier to express a particular mapping rule within scripting code. You could use the custom scripting functoid for that. Another situation that you might encounter is that you might need to copy an element and all of its children wholesale from the source document to the destination document. You might find that it's easier to use the advanced functoids for that type of mass copy. There are also some advanced functoids that you can use for diagnostic purposes. You can declare assertions, for example. And in another situation, you might have a destination schema that has an element that's marked as nillable, meaning that the element might be present, but its value is nil, in which case it's marked with a special attribute. There is an advanced functoid that allows you to handle that case, to set an element in the destination document as nil. Now, if you find that the default looping behavior doesn't meet the needs of your application, you might want to take a look at the advanced looping functoid. And this can help you in a couple of scenarios. For example, suppose you had an order with a collection of line items, but you only wanted to copy certain line items over to the destination document. Perhaps each line item has a product category code. You might have a category called hardware and another category called software. And perhaps your map should only copy the line items that are in the category of software. You can use the looping functoid to implement that type of condition. The default behavior, of course, is just to copy everything. Another situation in which the looping functoid can be useful is if you have two groups of records in your source schema that need to be copied to a single group of records in the destination schema. If we revisit the line item example, in this case we might have all of the line items categorized as hardware under a node named hardware. And we might have all of the line items that fall in the software category under an element named software. So now our map needs to take those two separate lists perhaps and combine those into a single list of line items in the destination. So if we created a link from the hardware node to our destination record, and then we also created a link from our software node to our destination record, to us it would look like we should have two loops that would create this single list. But unfortunately, the map compiler won't actually recognize that second link that we created from the software record. Instead, we would need to use the loop functoid to explicitly state that we want the map compiler to create two separate loops, one to iterate over all of the hardware line items and one to iterate over all of the software line items. So in addition to the looping functoid, you'll find a functoid that gives you access to the current index of the loop, as well as a functoid that gives you access to the record count. In some cases, you might encounter situations in which your source document is providing repeating records to you, and your destination document expects repeating records of a certain format as well, but you just can't get those to map directly over. What you can do is you can use the table functoids. In other words, you can use the table looping functoid to build an in-memory table of those records from the source document, and then you can use the table extractor functoid to read out the values of that table to create the structure that you need in the destination document. The BizTalk mapper also provides a set of functoids for interacting with a database. So for example, if your source message is going to provide some information about a customer, perhaps the customer ID and customer name, but your destination schema also requires a street address and phone number, it may be the responsibility of your map to fill in that missing data. And so one option that you have is to use the database functoids. You'll find these under the Database tab in the Mapper toolbox. It doesn't provide a way to call a stored procedure. And you will, of course, need to consider the performance impact of issuing a query to a database. If you can live with both of those conditions, then you might want to move ahead with the database functoid. So to use it, you drag a database functoid onto your map surface and drag a link from your source schema to the database functoid to provide the key value for the lookup. And then you'll need to provide a connection string, a database table name, and then the name of the column of the lookup value. And then at runtime, when BizTalk issues the query to the database functoid will receive back an ADO dataset populated with the query result. If the query result contains more than one row, your map will only see the first row of that result set. Once the database lookup functoid has the result set available, you're going to need to use another functoid to extract individual column values, and that's the purpose of the value extractor functoid. You drag a value extractor functoid onto your map surface for each column value that you need to read. And then you connect the database lookup functoid to each of those value extractor functoids. And then you also configure each value extractor functoid with the name of the column value that it should extract. And then finally, you connect each of those value extractor functoids to their corresponding node in the destination document. Now in a situation like this, of course, you're going to need to deal with error handling. And that's what the error return functoid is for. If you connect an error return functoid to your database lookup functoid as well, then if the database ever returns an error, the error return functoid will extract the error message, and then you'll need a field in your destination schema that can accept that error message. So if your destination schema doesn't have a node to accept the error message, you have a couple of options. If it's acceptable to modify the destination schema, of course, you could simply add an error message node. On the other hand, if that's not a possibility, you could create a new schema that wraps your destination schema. And this new schema could contain these types of application-specific nodes. And you could map to that instead. And then at some point, of course, this message would need to pass through another map that would extract the body of the message, in our case the purchase order. And so then that map would discard all of the application-specific nodes. And your purchase order could be sent on to its destination. So the database functoids offer one solution if your map has a requirement to fill in missing data. And you might find it more practical to write your own data access code and use a scripting functoid to make a call to it. We'll talk about that next. Now, if you find that the built-in functoids just don't meet the needs of some part of your map, you have a couple of options. It's possible to create your own custom functoids. You'll need to create a class library project and implement BizTalk's base functoid class. Once you've done that, you can add your functoid to the mapper toolbox, and then you can use it just like any of the built-in functoids. Now that might be worth it if you're going to use that functoid many times across many different maps. However, the other option that is available to you is that you can use the scripting functoid. It might take a few extra mouse clicks to configure the scripting functoid, but in a lot of cases you'll probably find that it's sufficient. There are a few different ways to use the scripting functoid. The one that offers the most power, of course, is using it to call a method in your own assembly. In order to do that, your assembly will need to be deployed to the GAC. But once that's done, when you add a scripting functoid to your map, you can select the option to call an external assembly. Then you select the name of your assembly. Then you will need to configure the inputs of the scripting functoid to match the list of parameters of the method you're calling. So you might do that by dragging links to the scripting functoid, or perhaps for some of the parameters, you need to configure those as hard-coded values. And you can do that in the scripting functoid's configuration page. As far as what the method actually does and how it goes about its business, that's entirely up to you. Now, at runtime, when the map executes, it will pass the parameters to your method, and your method can go ahead and do its thing. The big limitation here, though, is that your method needs to return a simple type. XSLT operates on strings. So if you return a .NET object, it won't know what to do with that. So sometimes you'll need to write a wrapper method that knows how to extract a string value from an object. Now I mentioned that you might consider using the scripting functoid if the database functoid doesn't meet your needs, and that opens up some nice possibilities. For one, it gives you the option to call a stored procedure. Another possibility is that you could implement some sort of a cache mechanism, so you don't need to pay the price of a round trip to the database every time. And that could be useful in the case of code conversions. If you have large lists or tables of codes, you could cache those values and those conversions would execute very quickly. And sometimes it makes sense to use the scripting functoid, even if you could get the job done with the built-in functoids. But sometimes you have to end up using the same pattern of built-in functoids over and over again. So it might just be easier to encapsulate that sequence of operations into a method, and then use the scripting functoid to call that method. By the way, I've sort of focused on data access scenarios for the scripting functoid, but obviously you could take advantage of other features of the .NET framework, perhaps to do encryption or decryption of some particular field, or to calculate a digital signature. Or maybe you need to implement a simple validation rule that you use in many places. Now the scripting functoid also offers the option to call inline script. I really consider this to be two different options because there are two different styles of scripts. The first style would be to provide your script in the form of Visual Basic, C#, or JScript. And this kind of provides a shortcut in a way, in the sense that you don't have to compile an external assembly and deploy that. But the disadvantage of this approach is that you won't be able to reuse that method. So if you needed to call that method in more than one spot, you would need to copy and paste that code, and you would actually need to give each of the copies of that method a unique name. So that can turn into a real maintenance headache if you have to make changes. However, if you just need to use a few lines of code, and you don't need to reuse that code elsewhere, probably the right option. The other style of inline script is to actually provide a snippet of XSLT. And there are two ways to go about this. If you simply provide a few lines of XSLT, and you connect those to a node in the destination schema, when the mapping compiler is generating the XSLT for the map, and it reaches that node, it will insert the lines of XSLT that you provide in the inline script. And that can be useful if your destination schema doesn't define the structure of the message that you're trying to create. For example, if the destination schema includes one of those XSD any elements that kind of leaves the door open, you might need to use XSLT inline script to define the structure of the data that needs to be inserted at that point. If you're familiar with the XSLT syntax, it's fairly straightforward to use this style of inline script. But one limitation that it has is that it cannot make use of the output of a functoid. If you need to do that, then you will want to make use of the XSLT call template type of script. So in that case, once again, you will add this scripting functoid to your map, connect that to a destination node, and then you would need to provide an XSLT call template, so this can accept parameters. And then of course you need to provide the links or hard-coded values to initialize those parameters. So the BizTalk mapper really provides you with a wide range of options. By taking advantage of simple links and the default looping behavior that the map compiler implements, and as needed making use of the basic functoids to combine and alter values, and then by taking advantage of the advanced functoids to take more control over the looping of your map and so forth. All of that capability rounded out with the options that the scripting functoid provides, it's pretty safe to say that the BizTalk mapper should be able to give you what you need. Now, having said all that, if you have an existing XSLT file, or perhaps you need to take advantage of some other XSLT capability that you don't see built in. Sorting would be an example. You can set a property on your map and specify that you want to provide a custom XSLT file. You will also need to configure the source and destination schemas. And then when the map compiler compiles that particular map, it will add it to the assembly. And at that point, that particular map will appear just like any other BizTalk map. It will be treated no differently. The one disadvantage there is you won't see anything on the map grid. You won't be able to use functoids and so forth to work with that map. In this demonstration, I'll show you how to add a looping functoid to a map. And in this case, the map should only copy records over that meet certain conditions. In particular, the source messages arriving could potentially have line items that could have a quantity of 0. And those line items should not be copied over to the destination message. So then I will add a greater than functoid to check the quantity of the item before the map copies the record over to the destination. Okay, so we're back to the map that we've seen in the earlier demos, and now we can add the looping functoid to filter out the records that have quantity of 0. So we can go find the looping functoid under the Advanced tab. So here's the documentation that describes how you can use the looping functoid. So I'm going to connect the item from the source schema to the item from the destination schema through the looping functoid this time. Now we can add the greater than functoid to implement the condition. Drag the quantity field to it, and then configure the parameters. So we want to check if quantity is greater than 0. And then we connect that condition to the item in the destination. So you could think of this as saying, for each item where quantity is greater than 0, copy that to the item in the destination. And now we can test. And there we have it. We only have the items that are greater than 0. In this lab, you'll have a chance to add a new map to a BizTalk project. And this map will convert a sales order message from its raw flat file schema to the sales order XML schema. You'll be able to try out the mapper's link by name and link by structure features. You'll have a chance to use some of the basic functoids. And then you'll also have a chance to try out the database lookup functoid.